Um, Hi, a very good evening. Today I'll be presenting about AC motors under the unit of electric and servo system for the robotics. Okay, so this topic is a part of our robotic sensor actuators. So let's explore the what is AC motors, and then what is the role of AC motor in robotic systems. Okay, so next, what are the topics we are going to discuss here? We are going to discuss this topic by using design thinking approach. It is a US centered and interactive approach that helps navigate the trade-off of robotics activations instead of just comparing the data sheets. Design thinking help us to deeply understand the what the system actually needs. Okay, so we'll go through the five stages like empathize. So understanding the users and system challenges, and then define, framing the core problems, and ideate, generating the possible solutions, and prototype, testing the concepts. Okay, so by the end you will see how the thinking improve the selection of systems of the design thinking approach. Okay, next, we can see about what is the AC motor. So AC motor is an electromechanical device that converts the alternating current of electrical energy to the mechanical energy through these interactions. It is operated through the interaction between the magnetic field in the stator and induce the current in this rotor, which produce the rotations. Okay, is a basic principle which we have to think about it. Okay, I'm repeating again. So in the AC motor, it's a electromagnetic mechanical device that converts AC current, that means alternating current, electrical energy into the mechanical energy through the interaction between the magnetic field in the stator and the induced currents in the rotor. Okay, so why AC motors matters, that we can see in our empathize. Okay, so in empathize, in model control system, AC motor had several limitations like variable frequency drive systems. A motor could only run the fixed speeds determined by power supply frequency and number of poles. Okay, so this caused energy losses, frequent mechanical wears will become, and then poor process controls. Okay, these three things you have to consider, like energy loss, and then frequent mechanical wear, and then poor process control. Okay, if we think empathically, operators were frustrated. They could not weigh the speed and motor heat too, and then engineers were think about complex data circuit, and then manual fault too, and then for the troubleshooting conditions. Okay, and then for managers worry about the high energy bills, and then downtime conditions. Okay, so these are things we can rectify by using the AC motor, by connecting the IoT systems and the AI systems. Okay, so next, we can move to the our defined stage. So in the defined stage, we have a problem statement like how we can achieve the precise and efficient speed control in the AC motor system while minimizing the energy loss and mechanical wear. Okay, so we have to control energy loss and mechanical wear. We have to consider. Okay, for solve those problems, we have some key requirements like reliability to ensure stable continuous operation, flexibility, allowing integration with the different control devices and sensors, efficiency, optimizing the energy and enabling the predictive maintenance systems. Okay, the solution, VFD based closed loop control system which combine variable frequency control with the feedback and smart monitoring systems. Okay, so in ideate we have some one more AC motor architecture. So in AC motor architecture, so stator creates the rotating magnetic field, and the rotor interacts with the field with the rotates, and then shaft transmits the motion to the mechanical load, and enclosure the bearings provide the support and protection for the smooth operations. Okay, so those are the important components which are available in the AC motor, like stators, rotors, shafts, and then supporting bearings. Okay, so stators, which is used for to create a rotating magnetic field, a rotor to interacts the with this field to and rotates, shaft transmit the motion into the mechanical load, and then finally the bearing support provide the support to the all smooth operations. Okay, so in the prototype we have some timelines like how it's evolved in the 1970s and 80s. Okay, in the 1970s the people are used induction motors for the fixed speeds. In 1980s VFD introduced for enabling the variable speed controls. In 1990s digital controls and vector controls are techniques improved for the precision controls. In 2010 and 2020 people are used IoT based controls, AC motor systems, and then many kind of IoT based systems are used. Okay, so these are the about the about the AC motor systems. So remaining things we can see in our next video. Thank you for watching. Thank you.